given the values for electronegativity during your exam, or you memorize all of those? So it depends on the difference in electronegativity between the two atoms in a bond. So we start with hydrogen-hydrogen bond. The difference with this is 0. Therefore, this is non-polar. Then for hydrogen fluorine, the difference is from the periodic table, if you're gonna subtract it, is 1.9, which is polar or very polar. Then for hydrogen chlorine, the difference is less than 1, 0.9. Still polar, but moderately polar. And hydrogen bromine bond, the difference is 0.7, still polar but slightly polar. So the most polar here is the hydrogen fluorine bond. So the answer there is letter B. You got that? Then for number 3, covalent bonding is best described as the electrostatic attraction between oppositely charged ions, positive ions, and the localized electrons, a shared pair of electrons, or two nuclei and a shared pair of electrons. So what are covalent bonds? A covalent bond forms when two atoms share a pair of electrons. So this bond, the covalent bond, is due to the electrostatic attraction between the positively charged nuclei of the two atoms and the negatively charged shared electrons between them. So the answer here should be letter D, right? Okay. The answer should be letter D, two nuclei and a shared pair of electrons, because letter C, it only has a shared pair of electrons. But it doesn't explain the electrostatic attraction that defines the bond. For letter B, that is positive ions and the localized electrons, that describes the metallic bonding. And for letter A, oppositely charged ions, that is not covalent. If it's oppositely charged ions, then that means that is ionic bonding. All right, so the answer should be letter D, two nuclei and a shared pair of electrons. Then for number 4, okay, number 4 here, which is correct for tetrafluoromethane, CF4? Bonds, polar, molecule, polar. Okay, so we're given here the molecular structure of tetrafluoromethane, CF4. So which one here? The bonds of, that is carbon fluorine bond. So you get the difference in electronegativity between carbon and fluorine. It's polar, right? The bond between carbon and fluorine. Fluorine here is much more electronegative than carbon, and based on the given molecular structure, this molecule is tetrahedral and symmetrical, so the bond dipoles here cancel out, right? So it is polar, but polar bonds. The bonds are polar, but the molecules are non-polar. The answer should be letter C. So the bonds, the carbon-fluorine bond is polar, while the molecule is non-polar. Okay. We're on number 5 now. We're on number 5. Which pair of ions gives the strongest ionic bonding? So we have sodium ion and fluoride. And then we have potassium and bromide, and then magnesium and oxygen, then calcium and sulfur. So which pair here gives the strongest ionic bonding? So how do we determine the strength of ionic bonding? The strength of ionic bonding depends on the charge of the ions. The higher charges, the stronger attraction there is. And then number 2, it depends on the distance between the ions, or the ionic radius. The smaller the ions, the stronger the attraction. So the higher the charges, the stronger the attraction, and the smaller the ions, the stronger the attraction. So let's take a look at the first choice. We have sodium here and fluorine. The charges here are plus minus 1, potassium and bromine still plus minus 1, but they have larger ions. Larger ions, that means weaker bonds. Then this one, magnesium and oxygen, the charges are plus minus 2, and they are both small. So this is, the bond between them is very strong. While calcium and sulfur, the charges are both plus minus 2, but the ions are larger. Therefore, it has, what's this? Weaker bond. Therefore, the answer here should be letter C. Yeah, because the first two, sodium and fluorine, potassium and bromine, calcium and sulfur, they have weaker bonds, and the strongest here is magnesium and oxygen. So the answer should be letter C. Then we're on number 6. Number 6. Okay. In 1.31 grams of chloride, of a chloride, really? In 1.31 grams of a chloride of titanium, that's chloride of titanium, there is 0.528 grams of titanium. What is the empirical formula of titanium chloride? What is the charge of titanium? What is the charge of titanium? Is it plus 2, plus 1, plus 3, plus 4? Okay, we just need to solve it so we can, we will know. Okay, so we're given here the molar masses of titanium, 47.9 grams per mole, and then for chlorine, that is 35.5 grams per mole. All right. So we just need to convert the grams to moles. So we're given here 0.528 grams of titanium. Then we convert this to moles. So we divide this by its molar mass, which is 47.9 grams per mole. Then this is just equal to 0.0110 mole of titanium. And then we also convert chlorine. We get the number of moles of chlorine. So that is 1.31. No. It says here we need to calculate the mass of chlorine first. From the given 1.31 grams of sample. So we subtract the mass of titanium from here, which is 0.528 grams. Then we get the mass of chlorine, which is 0.782 grams. Then that one we convert to number of moles. So from 0.782 grams of chlorine, divide this by the molar mass, grams per mole of chlorine, we get 0.0220 mole of chlorine. So we now find the simplest ratio. Okay, so we can divide the smallest number of moles. So the smallest number here is 0.010. So for titanium, that is 0.0110 divided by 0.110, that is 1. Then for chlorine, that is 0.220 over 0.0110. That is, I think that is 2. Yeah, 0.0220 divided 0.0110. So that is 2 moles. Therefore, our empirical formula for this one is TiCl2. Okay, so that is the formula of titanium chloride, and that would be letter B. Now we go to number 7 of this one. Okay. Which isotope is used as the standard in definition of relative atomic mass? What does this mean? Which isotope is used as a standard in the definition of relative atomic mass? It should be carbon, right? But which carbon here? We have carbon 12 and carbon 13. So the relative atomic mass scale is defined by assigning the isotope carbon 12, or we write it in that way, as an exact mass of 12 atomic mass units. And all the other atomic masses are measured relative to this standard. So this is the isotope that is used as the standard in a definition of relative atomic mass. So the answer here should be letter B. Neutral atoms always contain the same number of protons and electrons. Neutral atoms always contain the same number of protons and neutrons. Electrons have a relative mass of 1 and a charge of -1, or protons have a relative mass of 1 and no charge. So what are subatomic particles? Okay. Take note that in neutral atom, the positive charges from protons are balanced by the negative charges from electrons. Therefore, the number of protons is equal to the number of electrons. So let's take a look at the choices here. A, it says neutral atoms contains the same number of protons. Okay, that one is correct. That should be the answer. But the rest of the choices, we have B. Neutral atoms always contain the same number of protons and neutrons. This is false because neutrons can vary depending on the isotopes. And for letter C, electrons have a relative mass of 1 and a charge of -1. This is also false because electrons have a relative mass that is not exactly equivalent to 1, but 1 over something, like 1 over 1,800 something. And then for letter D, protons have a relative mass of 1 and no charge. And this is also false because protons have a positive charge, and it doesn't, it's not no charge. So the answer here should be letter A. Then for number 9, okay, number 9. Are atoms of an element that have different electronic structures, number of electrons, number of protons, number of neutrons. The answer here should be number of neutrons. Isotopes are atoms of the same element, so they have the same number of protons and electrons, but they have different numbers of neutrons. And this difference in neutrons gives them different mass numbers. The best, okay, number 13, which of the equation for the second ionization energy of an element A? Okay, so what does the second ionization look like? Second ionization energy is the energy required to remove one electron from a singly charged ion. Say a plus 1 charge. So we can write this as, for the second ionization energy, we can write this as A, okay, plus, okay, 2, and then we remove 1 electron. So let's take a look at the choices here. Okay, the first one, letter A, it removes 2 electrons, and letter D, so those are not the answers. So our choices are just between B and C. But letter C, it has 2, the charge is plus 2. It removes 1 electron. Yeah, but it's not the second ionization energy. Yeah, letter C is shows the third ionization energy, so it should be letter B. Okay, and for number 14, the bar chart shows the melting temperatures in the first 20 elements. Okay, the bar chart shows the melting temperatures of giant covalent structures are the highest in period 2 and period 3. Then metals are always higher than non-metals. Increase going down each group, increase across period 2 and period 3. So how would you identify here the period 2 and period 3 from the graph? So this is melting temperature in Kelvin against the atomic number. So what is the relationship between the atomic number and what's this? The structure. Metals are always higher. Melting temperature of metals are always higher. Okay, it says here that the answer should be letter A. Shows that melting temperatures of giant covalent structures are the highest in period 2 and period 3. Then number 15. I hope you've memorized the Aufbau principle in writing the electronic configuration, which is the electronic configuration of what is SC? SC plus 3 ion. SC is scandium. Alright. Okay. For neutral scandium, atomic number from the periodic table, its atomic number is equal to 21. So its electronic configuration from the Aufbau, using the Aufbau principle, you can write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So 2, 4, 6, 12, 18, 19, 20, 21. Okay, this is for the neutral scandium. But how about the scandium ion? Okay, so scandium 3 plus ion, this means that it has lost 3 electrons. So that means the first 2 are lost from the 4s here orbital, and the third is lost from the 3d orbital. Therefore, the electronic configuration of Sc3 plus would become 1s2, 2s2, 2p6, 3s2, 3s2 and 3p6. So this should be the answer. That is letter A. Okay, we're on number 16. What is the name of the product when the molecule reacts with chlorine gas? So what is the name of the product for that? 5,5-dichloro 2-methylpentane, 4,5-dichloro 2-methylpentane. Okay, what do we have here? We're given this skeletal structure. So we have how many carbons here? 1, 2, 3, 4, 5. So that's pentane. And then one methyl is attached to the second carbon. Is it? Or we count from here, right? We start counting from here. 1, 2, 3, 4, 5. So the methyl is attached to the fourth carbon, so it should be 4-methylpentane. And then the chlorine, it has 2. Okay, where is it attached? The chlorine, the first one right here, the first and second carbon. So the answer should be dichloro attached to the first and second carbon. So 1,2-dichloro 4-methylpentane. So the answer here should be letter D. Okay. Then for number 17, what type of bond breaking? What type of bond breaking occurs in this process? So we're given here H2O is broken into H plus hydroxide. Is this electrophilic, heterolytic, homolytic, ionic? So what type of what's this? Bond breaking. So we're given here this equation. Water here is dissociated into hydrogen, ion, and hydroxide. So that means the type of bond breaking where one atom takes both electrons. It should be okay. A is electrophilic. Electrophilic. This is not bond breaking, the electrophilic, because this one describes a type of reaction. And for letter B, this is heterolytic. So this one is a bond breaking. So the answer here should be letter B, heterolytic. And the third one, that one is homolytic, which means that the electrons split evenly, forming radicals. But in this case, for the water dissociation, there aren't any radicals formed. In letter D, ionic, this one is a non bond breaking process. Ionic describes the product type. What reagent and conditions are used for this conversion? Okay, potassium manganate 7 in aqueous acid, sodium hydroxide in dilute aqueous solution, steam and acid catalyst, steam and nickel catalyst. So how do we do this? We're given here the structure of hydrocarbons. Right, CC hydrocarbon to carbon to carbon bond. The first one, the first structure is the structure of a hydrocarbon to carbon bond with alcohol. OH is alcohol. So that means the conversion is from alkane to alcohol. So let's identify what kind of reaction, what type of reaction between them. Oh, no, it's double bond. It should be a double bond. It's alkene. Got a carbon-carbon bond. So it's a double bond. So that means this is hydration of an alkene. And when we say hydration of alkene, because we add hydrogen and hydroxide across the carbon double carbon bond. So usually this reaction uses steam or water gas and an acid catalyst. So typically concentrated sulfuric acid or phosphoric acid at high temperature and pressure. So the answer here should be letter C, steam and acid catalyst. Then for number 19, butene shows geometric isomerism. What are the prefixes that could be used in naming this isomer? So in naming this isomer butene, so we can use the prefix CIS and Z. Eliza, are you still there? Yeah, for butene, that is CH3CH. Have you what's this? Have you reviewed on EZ? CISZ, EZ isomerism, CIS trans? We discussed this many times, like in the previous papers. So for butane here, which has this chemical formula, has two identical groups on each carbon of the double bond. This one. We have the hydrogen and a methyl group. So that means this is CIS trans or EZ isomerism. No, it should only be CIS. What am I doing? So CIS. So this is a CIS isomer because the two CH3 groups are on the same side of the double bond. Yeah, notice this. Then we apply the easy system. So using the what's that rule? So the high priority group there here is CH3 and the lower priority group is hydrogen. Since the CH3 are on the same side, so this is Z isomer or the Zusammen, that one. So the answer here should be letter B. And then for number 20, which is the major product of this reaction? So we have hydrogen bromine, and then we have an alkene. So 21, magnesium carbonate. So we have MgCO3 plus 2HCl, then MgCl2 plus water plus carbon dioxide. It says complete the equation for this reaction by adding the state symbol. So it should be magnesium carbonate should be solid, and then hydrochloric acid is aqueous, then magnesium chloride aqueous, water is liquid, then carbon dioxide is gas. Magnesium carbonate here is a solid or a powder, and hydrochloric acid and magnesium chloride are aqueous because they dissolved in water. And then carbon dioxide, this one is the gas that is released from the reaction. A student carried an investigation to determine the molar volume of carbon dioxide using the apparatus. Okay, the student carried out 5 experiments adding a different mass of magnesium carbonate each time. The results are shown in the table. So that is for letter B. 21B. So what's the question here? Okay, the results are shown in the table. Plot a graph of these results. So we plot all of the points there. So I think this is a linear equation. Yeah, because as the mass of magnesium carbonate in grams increases, the volume of the gas collected in cubic centimeters also increases. So the graph of this should be linear. So I think that will be easy for you to graph. When the mass is 0.05 gram, then the volume of gas is 11 cubic centimeters. Then for the second one, a student carried out a further experiment using a different mass of magnesium carbonate. Give the volume of the gas collected using the inverted measuring cylinder. Oh, how do you do this? It says inverted. So you just count here 40, 41, 42, 43, 44, 45, 46. So the dark part, the lowest, what's that? The lower meniscus. I think it's the one. So the answer here should be 46 cubic centimeters. And then for the next one, determine the mass of magnesium carbonate added in experiment using your graph. Mass of magnesium carbonate added in the experiment. So we just have to calculate here. We get the molar mass of calcium carbonate, and then the moles of calcium carbonate, and then its molar volume. I'll send you the calculations later because okay, I checked the answers here. It's confusing. All right, Eliza, like last time, I will send you the calculations. Yeah, and this one too, the fourth one, that one is calculation. Okay, for the fifth one, the acid must be in exist for each experiment. Calculate the, okay, that one is also calculation. Calculate the minimum concentration of hydrochloric acid. Okay, that one is also calculation. I will send you that. The value of molar volume calculated in B was lower than the student expected. Give 2 reasons for the value being. Okay, we need the calculation for that. Then we go to number 22. This question is about fuels and polymers. Okay. Used coffee grounds have been suggested as a carbon-neutral fuel to replace some fossil fuels. Explain why coffee grounds might be considered a carbon-neutral fuel. You want to answer this, Eliza? Explain why coffee grounds might be considered a carbon-neutral fuel. So coffee grounds are considered carbon neutral because the carbon dioxide released when they are burned was originally absorbed from the atmosphere by the coffee plants during photosynthesis. So when you burn the used coffee grounds, you're only returning to the atmosphere the same carbon dioxide that the plant had already taken it. So meaning there is no net increase in atmospheric carbon dioxide. So that should be the answer. Yeah. And you can also add the carbon dioxide released on burning is equal to the carbon dioxide absorbed during plant growth. Okay. And that implies carbon neutral fuel. And then for the second one, explain how the use of fuels causes climate change. So how do fossil fuels causes climate change? All right. So the use of fossil fuels, what are those fossil fuels? Examples are coals, oil, and natural gas. They cause climate change because when they are burned, they release carbon dioxide and other greenhouse gases into the atmosphere. So that should be your number one answer. And these gases trap heat from the sun, and this process is called the greenhouse effect. So the more carbon dioxide builds up, the more heat is trapped, leading to a rise in global temperatures, and that is known as global warming. And this warming causes changes in the Earth's climate. We will be experiencing melting of polar ice caps, rising sea levels, or extreme weather conditions or patterns like we have storms and so on. So that means burning fossil fuels releases carbon dioxide, then enhances greenhouse effect, and causes global warming, and that leads to climate change. Then the next questions for letter B. Where is that? Long chain alkanes are not normally used as fuels as they produce soot. Name another pollutant formed by incomplete combustion of alkanes. So what is that other pollutant? Let me check. This is 22b. Let me check from your paper if okay. So you can answer here, name another pollutant formed by incomplete combustion of alkanes. So you can answer here carbon monoxide. Okay, just answer carbon monoxide. And then write the equation for the complete combustion of octane. State symbols are not required. So octane, it has 8 carbons and 18 hydrogens. So it says complete combustion. I see. It's different from your paper. So from your paper, this is the formula that is accepted from your paper. It's oxygen. You balance this. This is 12 and 1/2 atoms of oxygen, then 8 carbon dioxide plus 9 molecules of water. Okay, but you can always you can write it in this way, but from your paper the answer is this one, but you can write the it says incomplete. Okay, so you just answer this one, because when you write it this way, when you balance it this way, this is complete. 16 CO2, 18 water. So this one is complete combustion, this one is incomplete. Then for letter C, is this long chain alkanes are converted into smaller, more useful molecules, including alkenes. Name this process. So what is this, or what is this process? Alkanes converted into smaller, more useful molecules, including alkenes. So let me check from your paper. It says here bromine water, bromine solution. Okay, so the process here, long chain alkanes converted into smaller, more useful molecules, including alkenes. So the process should be named cracking. So you can test the alkenes by using reagents like bromine water. So test for alkenes using bromine water. Because the one in your paper, it's confusing. So the process is known as cracking, and then you test for alkenes. You use a reagent which is bromine water. This is an orange brown solution. Okay, and the positive result here is the bromine water is decolorized. It changes from orange to colorless. Give a test for alkenes including the positive result. So the positive result is it changes from the color of the bromine water changes from orange to colorless, or you can just simply say the bromine water is decolorized. Okay, then for letter D, alkenes such as ethene. Can you still see me writing on the board? Alkenes such as ethene can be used to make polymers. Write a balanced equation for the polymerization of ethene. Okay. Using displayed formula. Displayed formula, so you're gonna draw a structure here. So balanced equation of for the polymerization of ethene, it should be this one, NCH2, CH2, then okay, CH2, CH2, N. Okay, then it says displayed formula, so we can draw this carbon double bond, then hydrogen attached to it, and then into, how come it's different here? Should be CH, or you can write just, you can draw just this one, carbon, hydrogen. Just follow what is on in the paper. All right, then next one, bananas produce ethene as they ripen. Okay, so just one advantage and one disadvantage of using ripening bananas as a source of ethene for polymer production. So let me check. One advantage and one disadvantage. So for the advantage of using ripening bananas as a source of ethene for polymer production, the ethene comes from a renewable and natural resources, or renewable and natural sources. Reducing dependence on fossil fuels and making the process more sustainable. And then this advantage here, the amount of ethene produced by ripening bananas is very small, making it inefficient and expensive to collect and use on a large industrial scale. So from your paper, acceptable answers for advantage: bananas are renewable resource, that one. And then one disadvantage: many bananas would be needed to produce a small amount of plastic, or bananas only produce small quantities of ethene. Then for the next one, I think this is the last question. Where's that? Burning polychloroethene in an incinerator results in the formation of hydrogen chloride. State a hazard associated with hydrogen chloride. So you can say, okay, hydrogen chloride is toxic and corrosive, or you can also say hydrogen chloride is poisonous, or hydrogen chloride is irritant. And then for the next one, suggest how the hydrogen chloride could be removed from the waste gases produced in an incinerator. So you can say using the use of basic or alkaline scrubbers or injection of powdered activated carbon, or you pass it through water, or dissolve the hydrochloric acid in water.